Thanks for attending my talk, everyone. The title of it is Scala's Hidden Treasures, 5 ZIO-compatible libraries you didn't know you needed. I'm Jorge Vasquez, and I work at Cyberg as a senior software engineer. So what I'm going to be presenting today, I'm going to be presenting 5 libraries from a user's perspective to handle diverse data processing tasks, all of them compatible with Scala 3 and ZIO. So the first one I will be talking about is Spata for stream-based CSV processing, then ZIO Apache Parquet for type-safe processing of Parquet files. Next will be YAML Forest for YAML processing, ZIO LMDB for high-performance embedded key value stores, and finally Transactio for integration between Dubi and ZIO. So let's start with the first one, Spata for stream-based CSV processing. So this library is a functional CSV processor. It offers a stream-based API backed by FS2, allows easy conversion between CSV rows and case classes, provides also, this is a nice feature, it provides precise information about possible flaws and their location in source data when there are some parsing errors. Well, let's see the library in action. For that, let's go through this example. Let's suppose we have a CSV where I have some chemical elements. So this CSV will contain 4 columns. We have the element, the chemical symbol, melting temperature in Fahrenheit, and the boiling temperature. And well, this is the actual CSV file. So you can see the first row contains the header, and the next rows contain the data itself. And also you can see that the columns are separated by commas, so a pretty standard CSV file. And well, to start solving this problem, first we need to do some domain modeling. And by the way, all the examples I'll be showing here are using Scala CLI. So well, first here in my script, I'm doing some imports. I'm defining the JVM version, the Scala version. I'm importing here the Spata library. I'm also going to need the ZIO interop cats library. Why? Because Spata is based on FS2 and cats, so we need the interop library if we want to work with ZIO. And I'm also going to be using ZIO schema. We'll see why in some moments. And well, the domain model will be very simple. I have a case class element with 4 fields, each one corresponding to a column in the CSV file. And I have this update temps function that I will be using later, basically to process temperatures, for example, converting from Fahrenheit to Celsius. Okay, so the first step for solving this problem will be parsing the CSV file we want to process, right? So for that, we have to define a CSV parser provided by the Spata library. So I'm doing some imports here. And you can see here, it's very easy to create a CSV parser. You just need to call CSV parser. And well, because this is a library based in cats, it's generic on the effect type. So in this case, I'm saying we are going to use ZIO for the effect type, specifically ZIO's task. And this will create a default CSV parser. So basically, the delimiter will be comma, the quote character will be double quotes, the first line of the file will be considered to be the header, and headers will be mapped to case class fields. So that's the default behavior. But what if I want to customize the parser? I can do that. So for instance, in this case, I would need to do some mappings between headers and case class fields. Well, in the case of the first field element, the header in the CSV file is the same, also for symbol, but for melting temp, the header is melting temperature in Fahrenheit. So I need to do a mapping between those and something similar for boiling temperature. So for that, the way of instancing the CSV parser will be calling csv parser.config, and you have this method map header that allows you to map headers to case class fields. So that's what I'm doing here. And after that, I can just instantiate the parser. There are other customizations you can do, but in this case, that's the only one I'm making. And once I have the parser, something interesting is that I can convert it to an FS2 pipe by calling the parse method on that. So basically, this returns a pipe that we can use later to process the data that we're going to read from the CSV file. We're going to see that in some moments. So that was the first step. The next step will be, well, what happens if at the end of the processing, I want to save the processed CSV file? I'm going to need a renderer for that. And that's what I'm doing here, defining a CSV renderer. And you can see the way of instantiating this is very similar to how we instantiate the CSV parser. This creates a default version of the renderer. And if you're wondering if we can customize the renderer, yes, we totally can. In this case, I want to do the same mapping between case class fields and headers, right? So that's what I'm doing here. But also in this case, I'm defining the delimiter, for instance. So I want the output file to use a semicolon for delimiting fields instead of commas, so I can do that. And here I'm doing the mapping from fields to CSV headers. So I have the renderer now, and I can also convert that to an FS2 pipe by calling the render method. So now that we have the basic blocks, we can start to see how to process a CSV file. So I'm creating a ZIO application here. And well, we have already defined our pipes for parsing and rendering. Here I'm defining the input and the output file. So the input will be a file with temperatures in Fahrenheit. The output will be in Celsius. And here I'm defining a processor. This processor will be like the core logic of my application. You can see it is an FS2 stream with task as the effect type. So how I can create this stream is very easy. First, you need to call this reader.read method from the Spata library, where you basically provide the path to the CSV file you want to read. And this will give you an FS2 stream of chars. So now, if I pass this stream through this CSV parser pipe, I will have a stream of records. So this record type is an internal type of the Spata library. That's a very generic type to represent rows in the CSV file. So I have that now. And well, because I want to work everything inside ZIO, I can convert this FS2 stream to a ZIO stream. And this is thanks to the interop library I have imported. And well, now that I'm in the ZIO world, I can use all the methods we know and love from ZIO streams. In this case, I'm mapping each record to my domain model. Remember, I have defined my element case class. So instead of working with these generic records from the library, I'm working with elements. So I can do that conversion using record.to. And now that I have my domain model, I can do whatever I want with that. In this case, I'm updating temperatures to be Celsius. And once I have done all the processing, in this case, that was the only processing I wanted to make, I will need to transform again to this generic record class. So I'm calling a toRecord method here. But actually, this is an extension method I have created for my element case class. Sadly, Spata doesn't have an incorporated method to do this, so I created one. We are going to see the implementation in some moments. And I have to go back to the FS2 stream world, so I'm doing that. And now I have, again, a stream of records, right? If I want to write that to a file, I have to convert this to a stream of chars. And for that, I'm using the renderer pipe I have already defined before. And finally, I can call writer.write from the Spata library, and this will return the processed CSV file. So that's very nice. And to run in the application, it will be just a matter of compiling the FS2 stream and running it. So, well, the only question that was left is how can I convert an element to a CSV record? Or even better, instead of just focusing on converting my domain class element, how can I convert any case class to a CSV record? So, well, there are many possible solutions, right? Maybe we can use macros or inline methods, or maybe shapeless or Magnolia. All of these will be valid solutions, but instead I'm going to be using ZIO schema, and that will make this task very easy. So, well, I need to derive a ZIO schema for my element case class first. So for that, I'm calling derive schema.gen. This returns automatically a schema of element. So that's very nice. Another thing I'm doing here is that Well, instead of returning a schema of element, I'm returning a more specific type. I'm saying this is returning a schema of record. This schema.record basically means that I'm returning the schema of a case class, right? And well, something interesting here is that this works. So I'm able to assign a more specific type because this derived schema.gen is a transparent macro. So transparent macros in Scala 3 allow you to see the underlying implementation type. So that's why I'm able to assign a more specific type here to my schema. And why I'm using this more specific type instead of using the generic schema type. Here is the reason. I'm defining my toRecord extension method that will work on NEA, but I need a schema.record, right? So this way I'm ensuring that this method can be called only on case classes, right? It won't be able to be called on CL traits because they are not records. So that's the reason I have chosen the more specific type. And now I can use ZIO schema to convert any case class to a record from Spata. So Spata has this record from pairs that accepts a map, basically, a map from keys to values, right? The keys will be the field names of my case class. ZIO schema gives access to the fields of the case class. So I have those, and I can also access to the corresponding values because ZIO schema does have this field.get method I can use. And now I have a very generic way of converting any case class to Spata records. So that was it for the first library. I'll go to the next one. Type-safe processing of Parquet files with ZIO Apache Parquet. So, well, this library is a ZIO-powered wrapper for Apache Parquet's Java implementation. It leverages ZIO schema derivation to automatically derive codecs. It also uses ZIO schema accessors to provide type-safe filter predicates. We're going to see what this is about. And something nice is that you don't need a Spark to read and write Parquet files. So that's a very nice feature of this library, and it supports streaming. So, well, again, the first step for solving this problem, I will be doing some domain modeling. So I'm defining the Java version, Scala version. Here I'm including the ZIO Apache Parquet core library. I'm going to be using Spat as well, because in my example, I want to make some conversions between CSV and Parquet. I need the interop library for cats and ZIO schema. Here I'm doing some imports of the Apache Parquet library. So, well, I have my domain model. I'm going to be working with the same CSV file I had before. So I have my element case class, that's the same. But now I have to define several implicits, several givens. So the first one is the schema. I'm going to need the schema for element again, but you can see that in this case, I'm using an even more specific type. So instead of using schema.record, as in the previous example, I'm using schema.caseClass4. And this is the most specific type for this schema. And well, the reason for that is that I'm going to need all the information at the type level about the fields and the column types. So you can see here in the type that I know what are the names of the fields and the corresponding types, and that's I'm going to need in some moments. I'm going to need to define a schema encoder. So this schema encoder is used to generate the corresponding Parquet schema when writing files. So if you remember, every Parquet file internally contains a schema, right? So this schema encoder will be the one in charge of generating that schema when writing Parquet. I'm going to need a value encoder. This will allow us to transform our domain model, in this case element, to a value. This value is a generic type in the Parquet library that basically defines all the possible types that Parquet can have, like strings or numbers, and so on. And we have value decoder for going the other way around. And here I'm defining something very interesting by calling this filter.columns method. This basically uses ZIO schema accessors under the hood and gives us precisely accessors to each field in our case class. And well, for this to work, I need the very specific schema type I have mentioned before. That's the reason I've done that. And these accessors will allow us to do some very type safe filtering on Parquet files. We're going to see how that works in a moment. And well, let's start doing what we need to process our CSV files, convert them to Parquet. Well, if I want to read CSV files, initially I'm going to define the CSV parser as in the previous example. And in this case, the effect type I'm going to work with is a RIO with a scope in the environment. Why I'm doing that for this example instead of using task? Well, the only reason for that is that ZIO Apache Parquet needs a scope in the environment. So that's the only reason I'm doing that here. But everything else will be basically the same. I'm defining a parser here, and I'm defining here a ZIO stream for reading from CSV and process the temperatures to Celsius. That's almost the same as the previous example. I'm also defining a renderer because, well, what if I want to read a Parquet file, process it, and then render it to CSV? So I can do that. I'm defining the renderer here, same as before. And I have this auxiliary method, write stream to CSV, that will take a stream of elements and write them to CSV using the Spata library. So that's very similar to what I've done before. And now that I have all the basic pieces, let's see how to work with Parquet. So initially I'm defining some paths here for the input files and output files, and I have my processor logic here. So you see this will be a ZIO effect that requires a Parquet writer and a Parquet reader. Those are from the ZIO Apache Parquet library. So well, initially, what if I want to read elements from the CSV and write them to a Parquet file? So here, well, initially I'm writing the Parquet schema. I can do that because I have defined already my schema encoder, right? So if I call schema encoder.encode, I will be able to see the Parquet schema that will be included in all the Parquet files generated. So here you can see it. And now I want to write the file itself, right? For that, I can call this write stream method that accepts the destination, the path of the destination, and the stream I want to write. In this case, the stream will read from CSV, process it, and that's the one I have already defined before. And that's it basically for writing a Parquet file. Now that I have the Parquet file, I can read it again just to show how that's done. So for that, you can call this read chunk method. So if you use read chunk, you are reading the complete contents of the Parquet file into memory. So maybe you don't want to do that because your Parquet file is very, very big and you don't want to fill the whole memory. So instead of using read chunk, you can use read stream. Other nice feature is that, well, as I have mentioned a little before, is that we can use filters when reading from Parquet. So there is this method read chunk filter that you can use to read your Parquet files, but you can apply some filtering at the time of reading. And this filter is type safe. And that's because we have defined these accessories before, thanks to ZIO schema. So here, for example, I'm filtering the element hydrogen and with a melting temp greater than 0. And all these comparisons I'm doing here will be type safe. So element is a string, melting temp is a double. So that will be, that's very nice because we are not working just with the strings, we're working with very specific types. And we have a similar method for working with the streams, read stream filter. And well, after all of that, for example, here I'm writing my Parquet file I have read into memory into a CSV using Spata. Finally, to be able to run the application, we need to provide some layers. We need this Parquet writer and Parquet reader. For that, we can provide layers, and the library provides two layers that we can use, Parquet writer.configure. Here in this case, you can see I'm doing some customization. I'm specifying that I want to overwrite a Parquet file if it already exists. And I'm also providing here the Parquet reader, and that's basically it. Once you have this, you'll be able to run the application and do the processing you want. Next library, YAML4S for YAML parsing. So YAML4S allows to parse a YAML string as a YAML data type or JSON. This YAML data type comes included in the library. And to parse YAML as JSON, there are several libraries that are supported, and one of them is ZIO.JSON. And I'm going to be showing that now. So, well, for this example, let's say we have a YAML file, in this case with information about persons, people. And so every person will contain several columns, several fields, for example, the name, the age, email, phone, address, location, a list of tags, a list of friends, and so on. And so for working with this library, well, first I'm doing some imports here, the Java version, the Scala version. Here I'm importing the YAML Forest backend library. And by the way, YAML Forest offers different versions for the backend. So there is a cross-platform backend you can use, or a JVM only backend, or a native only backend, or a JS only backend. And you will also need, in this case, I'm importing the library for integrating with ZIO JSON. There are similar libraries for integration with other JSON libraries. And well, for my domain modeling, first, I'm defining this friend case class because, well, every person contains some friends. So I'm modeling that here. And you can see I'm deriving JSON codec. This JSON codec is from the ZIO JSON library, and I'm able to use it with this derives keyword in Scala 3 because ZIO JSON implements the support for that. So that's very nice. And I have here my case class for person with all the corresponding fields, and this will also derive JSON codec. So now, well, let's see how to process this YAML file we had. Now that we have our domain model, I'm doing some imports here, ZIO stream, ZIO JSON. I'm importing the YAML Forest library and the integration with ZIO JSON. And well, a limitation that this library has is that it doesn't have methods to read from a file or to write to a file. It only works with YAML strings. So for that, because of that reason, I have needed to create these custom methods to read from a file into a string and to write a string into a file. So, well, these are very easy methods. They are just using ZIOStream under the hood. I'm not going to go into details here about that. Just know that they are auxiliary methods for reading and writing to files. So here I have my input file, my output file. And let's see. So for processing my YAML file, first I'm reading it. So now I have as a YAML string. And now I can use YAML Forest to parse that YAML string. I can parse it to a YAML data type using this backend.parse method, specifying YAML as the return type, or I can use backend.parse and return a JSON. So this JSON is a data type from ZIO JSON, a very generic JSON data type. But well, I don't want to work with a very generic type. I can transform it to my domain model. So in this case, I'm calling this JSON.as method, and I want to return a list of persons. And I can do that, yeah, because I've derived JSON codec when defining my domain models. So now I have a list of people. And now that I have a list of people, I'm using my domain models. I can do all the processing I want with that. In this case, I'm just filtering by tags. And once you have done all the process you want, and you want to store the results in a YAML file again, I will need to do some things. First, I will need to convert my domain model again to this JSON data type. ZIO JSON has this to JSON AST method for that. And once you have the JSON, you can use YAML Forest to generate a YAML string by calling backend.print. And now that I have the YAML string, I can just write it to a file using the auxiliary method I have created. And that's basically it. You can see it's a very simple library, and I have needed just to define some auxiliary methods. Next library, high performance embedded key value stored with ZIO LMDB. So LMDB means Lightning Memory Map database. It offers an embedded key value store. It's based on the LMDB Java library. It brings a higher level ZIO API, so that's the advantage of it. And it offers JSON-based storage using ZIO JSON. So the idea is that LMDB stores key value pairs, right? So values will be basically stored as JSON using ZIO JSON for that. And a very nice feature is that this library offers very precise error management thanks to Scala 3 unit types, and it supports streaming. So, well, for starting, we are going to do some domain modeling. Again, I'm defining the JVM version. I'm defining some Java options here. I'm not going to explain what these options are. Basically, in the README of the repo, it tells you to set these options. The Scala version, here I'm importing ZIO LMDB, Spata, well, because, well, I want to read as the CSV file we had, and I want to store it into LMDB for my example, and the interop library for cats. So I have my domain model for elements, the same as before. I'm deriving JSON codec. And now let's see how ZIO LMDB works. It's very easy. By the way, LMDB defines a memory database, right? And this database can have several collections. So here I'm going to create an elements collection, and I can do several stuff. For example, I can check if the collection already exists. I can create a collection. I can then list all the collections I have available in the database. I can load data into the elements collection. We're going to see how I'm going to do that in this separate method. Then I can collect all the data into memory from a collection, in this case, into a chunk. I can check the size of a collection. Then I can do whatever I want with the data I have collected. For example, here I'm just printing to the console. I can filter while I'm loading elements. Or if I don't want to load into a chunk, I can use streams, ZIO streams. So that's very nice. I can clear all the elements in a collection, or I can drop a collection completely. To load elements from the CSV file, I had this auxiliary load elements from CSV method. So for that, I'm defining my CSV parser from Spata, and I have here the load elements from CSV method. You can see the error type is very specific, and that's the thing I was mentioning. This is thanks to union types in Scala 3. And well, to read elements, I will basically use the same logic as before with Spata. I'm reading the CSV file, parsing it, transforming to my domain model, processing the temperatures to Celsius, and finally, to insert into the elements collection, I can use this element absurd override method. For instance, I need just to provide a key, which will be the symbol in this case, and the value will be the element transformed into JSON. And that will be basically it. And to run the whole application, I need to provide some layers. The database, in this case, it will be this elements database, and then we need to provide a ZIO scope. The final library, I have just 2 minutes, so I'll go very quickly. Transactio. This Transactio library is a wrapper for some Scala database access libraries. Doobie and the norm for now, I'm going to be presenting about Doobie today, and it supports streaming. So maybe you're thinking, do we really need this Transactio library to integrate Doobie and ZIO? Well, let's see. So first, I'm doing some domain modeling. I'm importing Doobie core, Doobie H2 because I want to use an H2 database, ZIO streams, and the interop library because I'm going to need that. And now this example is different from the other ones. I'm basing on an example I have found in the type level repository, where basically we'll be working with coffee suppliers. So I have the model for the coffee supplier. I have model for coffee. I have defined this list of suppliers and coffees here to be able to query them. And now I'm defining some Doobie queries. I'm not going to go into detail about how to define the queries. The only important thing here is that all these queries return a connection IO. So this connection IO is the data type, the effect type from the Doobie library that describes executing queries against a database, right? And well, Doobie also allows us to do streaming queries. So this will return FS2 streams of connection IO. I can do that as well. And well, I have here a query to create the tables I'm going to need. And well, if I want to work with ZIO, I need to transform these connection IOs to ZIO or ZIO stream. So to do that, I need to call this transact method on connection IO and provide a transactor. This transactor, I'm obtaining it from the ZIO environment, and I will need to do that all the same for all the queries, right? I can also convert to ZIO stream. So that's a little repetitive, right? So I can do some improvement. For example, here I can define some extension methods to do the same, to convert. For example, I have this transact ZIO to convert a connection IO to a ZIO, or transact this transact Z stream to convert to a Z stream. So now my queries get simplified. I just can use this transact ZIO or transact Z stream, and now it's a lot simpler. And now that I have converted to ZIO, I can combine all these queries at the ZIO level, right? So using a for comprehension in this case. And well, for an application, I will need to provide a layer, right? And well, I'm creating here an H2 transactor. Basically, it's a little complex, but I'm providing at the end a URL, a user, and a password. And I provide that layer, and that's it. So see, we don't need transactio, right? But well, there is a problem. What if we want to combine queries into transactions? So if I want to combine, for example, these insert suppliers and insert coffees into a single transaction, I have to go back to the connection IO level to be able to combine them into a single transaction. So that's not nice. And now that I have the combined connection IO, I have to convert that to ZIO again. And just after that, I will be able to use it in my ZIO application. So we can't combine them at the ZIO level. So there has to be a better way. And yes, transaction is to the rescue here. And well, now for converting our connection IOs to ZIO or ZIO stream, there is a simplification here that the library offers. We can use this TZIO method instead of creating a custom extension method as I have done before. So that's nice. And if I want to combine an FS2 stream to a ZIO stream, I can use TZIO stream. And this returns this transact IO or transact IO stream data types. And what are they basically? They are just type aliases, right? A transaction at the end is a ZIO effect that requires a transactor on the environment and that can fail with a DB exception, and something similar for transaction stream. So now that I'm using transaction, how do I do to run queries in my application? Well, one difference is that I will need to enclose all my queries inside transaction regions by calling this method database transaction or die. There are other methods in this database object. I'm using this one for the example. So in this case, I want to run every query in a separate transaction. So I'm calling transaction or die in each of them. I can also call transaction or die stream if I'm working with streams. And now, if I want to combine queries into a transaction, I don't need to go back to the connection IO level. I can just do the combination at the ZIO level, just enclosing the queries I want inside the same transaction region. And another nice thing is that I can use all the operators you know and love from ZIO to combine the queries. In this case, I'm using zip. Zip is a method you don't have in connection IO, for example. So that's very nice. So you can stay at the ZIO level. And for running the application, you just need to provide some layers, a database, the library provides you a layer for that, and the data source. And the data source is very easy to define. You define the URL, the user, and the password, and that's it. So that was a lot. So in summary, we have seen 5 libraries for data processing in Scala 3 compatible with ZIO and ZStream. You can seamlessly do CSV, Parquet, and YAML processing with Spata, ZIO Apache Parquet, and YAML 4S. You can integrate high-performance key value stores with ZIO LMDB, and Transaction allows you to do seamless integration between ZIO and Dubi, keeping everything at the ZIO level, including transactions. I'm going to include links to the repos and also links to the examples I've shown in the slides. I'm going to be sharing the link to the slides later today. You can contact me on Twitter, LinkedIn, or by email. Thank you very much.